Good morning everyone. Today I discussed about topic precious laws. What is meant by laws in precious concrete structures? Already been study in first unit pre-stressing force and post-tensioning force. So what is meant by pre-tensioning force means we have to give stress to the tendons before casting of the concrete is called as pre-tensioning of the structure. What is meant by post-tensioning? We have to give the stress to the stretching to the tendons after hardening of the concrete is called as post-tensioning of the structures. So during that phenomena, we have to see some losses will be occurred in the structures due to fixing of the auxiliary equipments to the beam structures and casting of the concrete and percentage of stress given to the tendons. Those are the points will be noted in the losses will be occurred. So here second unit we have to take in the losses. In pre-stressed concrete applications, most important variable is the pre-stress. So here compared to RCC, pre-stressed we have to take in as pre-stressing force. Pre-stress does not remain constant with the time. In RCC we have to see after construction of the building the pre-stressing the stress will be increased. But in the case of pre-stressed structures, pre-stress initially occur very more. After during the service period, the pre-stressing force will be reduced. So pre-stress does not remain constant with time. Even during pre-stressing of tendons and transfer of pre-stress, there is a drop of pre-stress from the initially applied stress. Is a drop of pre-stress from the initially applied stress. If you have given the pre-stressing force in the initial casting of the concrete, the pre-stressing loss will be occur high. During the construction or service period, the pre-stressing loss will be reduced with increasing of the time. Reduction of pre-stress is nothing but loss in the pre-stressing force. For example, if you have given the stress to the tendons 100 kN per mm square, but after construction or during the service period, you have to see the stress of the tendons, that is the reduction value will be seen in pre-stressing force in the after occurring construction in the structure. Pre-stressing loss. Early attempts to produce pre-stressed concrete was not successfully due to loss of pre-stress transferred to the concrete after few years. If we see the pre-stressing losses in olden days, the pre-stressing structures are not applicable in the previous years. Nowadays only the pre-stressed structures are randomly increased. Why? Because the losses will be high in past years. That losses will be reduced during the invention of the structures. Pre-stress loss is nothing but the reduction of initial applied pre-stress to an effective value. In other words, the loss in pre-stress in differentiate between initial pre-stress and the effective pre-stress that remains in a member. So loss we have to consider here is very negligible during the service time. That point we have to strongly notate it. So loss of pre-stress is a great concern since affects the strength of the member, also significantly affects the member serviceability, including stress in concrete cracking, camber and deflection. Concrete cracking, camber and deflection. So losses during the service period and strength perceptive we have to reduce the very negligible. So stresses in concrete cracking, camber and deflection we have to see the precious losses. So in precious losses we have to see two types of losses, very important in the competitive exam point of view. So compulsory one question will be arising in the scenario. So short term or immediate losses, long term or time dependent losses. What is mean by short term losses? We know that short term means immediate loss we have to see in the structure. Immediate losses occur during the pre-stressing of the tendons and transfer of pressures to the concrete member. Transfer of pressures to the concrete member. So if we have to give stress to the tendons, we have to see the initial loss in the structure that will be considered as a short term loss. That is also another name is immediate loss. So long term loss and time dependent losses. Time dependent losses occur during the service life of the structures. Service life of the structures. Time dependent losses occur during the service life of the structure. So during the service period we have to see the cracking, deflection, serviceability. So those are the long term losses. So for example, totally 6 losses is there in precious losses. First three losses are immediate losses, that is called as short term losses. Time dependent losses is another criteria. Immediate losses means elastic shortening of the concrete. Second perceptive is slip at anchorages immediately after pre-stressing. Third one is friction between the tendon depth and wobble effect. So elastic shortening of the concrete is a short term loss. Immediate we have to see the stress to the tendons. That is we have to see the shortening of the tendons, slip at anchorages immediately after pre-stressing. Next one is friction between the tendon and tendon duct. If you have to see the last classes, post tensioning we have to use as ducted material. What is meant by duct? So it is the intermediate member placing the tendon and concrete. The duct will be act as a stress transfer the concrete through the major surface of the structure. So friction between the tendon and tendon duct and wobble effect. Friction between tendon and tendon duct is called as wobble effect. So it is the short term answer, compulsory in see the external exams. Time dependent losses include creep and shrinkage of concrete, relaxation of pre-stressing steel. Relaxation of pre-stressing steel, creep and shrinkage. Creep and shrinkage of concrete. So creep, we have to see the cracks of the structures. In pre-stressed structures we have to see the very lesser value of the creep and shrinkage of concrete. Relaxation of stress of the concrete we have to see the time dependent losses. Time dependent losses. So here see the precious losses, immediate and time dependent, elastic shortening, friction, anchorage slip, creep, shrinkage, relaxation. So in pre-stressing systems we know two types of systems is there, pre-tensioning and post-tensioning. Pre-tensioning and post-tensioning, elastic shortening, that is occur in pre-tensioning. If you have to see the post-tensioning of the structures, elastic shortening may occur, may not be occur. That is, if all the cables are simultaneously tensioned, there is no elastic shortening in the post-tensioning. Anchorage, if cables are successively tensioned, there is a elastic shortening. Loss will be occurred in post-tensioning. Anchorage slip. There is no anchorage slip in pre-tensioning and there is a anchorage slip in post-tensioning. Friction loss. There is no friction loss in pre-tensioning. There is a friction loss in post-tensioning. Creep and shrinkage of concrete. Creep and shrinkage will be occurred in pre-tensioning as well as post-tensioning. Relaxation of steel will be occurred in pre-tensioning and post-tensioning of the structures. So, first one is elastic shortening of the concrete. Very, very important. It is the first loss we have to observe in pre-stressing systems. So, in pre-tension concrete, when pre-stress is transferred to concrete, the member shortens and the pre-stressing steel also shortens. Hence, there is a loss of pre-stress. In case of post-tensioning, if all the cables are tensioned simultaneously, there is a no loss. If successively tensioned, there is a loss. If the cables are tensioned sequentially, there is loss in tendon, there is subsequent stretching of the other tendons. Loss of pre-stress mainly depends on modular ratio. If you have to see the highest strength of materials, that is M40, M50 grade of concrete, F500 grade of steel you have to used as a tendons. In that scenario, there is less modular ratio, higher modular ratio, less elastic shortening will be occurred. So, loss of pre-stress mainly depends on modular ratio and average stress in concrete at the level of the steel. Loss due to elastic shortening is quantified by drop in pre-stress in a tendon due to change in strain in tendon. The change in strain in tendon is equal to strain in concrete at the level of tendon due to pre-stressing force. This assumption is due to strain compactability between concrete and steel. Strain in concrete at the level of tendon is calculated from the stress in concrete at same level due to pre-stressing force. Strain compactability we have to see in RC structures. Loss due to elastic shortening is quantified by drop in the pre-stress in a tendon due to change in strain in tendon. Change in strain in tendon is equal to strain in concrete at level of tendon due to pre-stressing force, which is called as strain compactability between concrete and steel. Strain in concrete at level of tendon is calculated from the stress in concrete, same level due to pre-stressing force. A linear elastic relationship is used to calculate strain from the stress. So, pre-tension members, when tendons are cut, the pre-stressing force is transferred to the member. Concrete undergoes immediate shortening due to pre-stress. Tendons also shorten amounts which leads to loss of pre-stress. How to calculate elastic shortening of the pre-stressed structures? Means the tendons will be cut. After cutting only, the stress will be transferred tendons through the concrete. That is considered as the elastic shortening. Tendons also shorten by same amount, which leads to loss of pre-stress. Post-tension. If there is only one tendon, there is no loss, because the applied pre-stress is recorded after elastic shortening of the member. If you have to see in post-tension structures, there is a one tendon, there is no loss. Why? Because we have to give tension in simultaneously, there is no. Furthermore, one tendon is stretched sequentially, there is a loss in tendons. So, it is the one of the structure we have to see in post-tension. That is a concrete block, and at the end auxiliary equipments are connected at the end of the block. Hydraulic jockeys connected at the end of the abutments. That through the hydraulic jock we have to give in the stress to the hydraulic jock. That jock will be transferred the stress to the tendon in a linear way. The stress will be transferred after cutting the tendon. The concrete member will be the depth of the concrete will be changes. This scenario will be after means elastic shortening will be occurred. The loss will be happened in the structure. So, post-tension members, if you have to give tendons, there is a duct is there. You have to give stress to the tendons. The duct will be transferred to the concrete. there is a no loss in the post tension members. Thank you.